होप सो सबके पास एक सेपरेट नोटबुक है इलेक्ट्रोमैग्नेटिक्स के लिए. Cylindrical coordinate system, and the coordinates are rho 5z or r 5z. Rho and r, that is the radius of the cylinders. So now to draw this, we have to consider the intersection of one cylinder, right? So here this is the intersection of the cylinder denoting the height of the cylinder, and this is the side part of the cylinder. Okay, and this is the row from the origin, right? Now this is the complete cylinder. You can imagine this is the complete cylinder, but we are considering this is the cross section, one cut section. So from this origin to this on the surface of the cylinder, this is the radius, that is the rho. So along this row, unit vector a rho is there, that is the cap. Don't forget the cap or bar, right? Along this row, that is along this radius, unit vector is a rho. Now this is the cylinder. So from this surface point to this bottom line, height is z. So along this z axis, unit vector is az cap. Okay. Now this r is radius, z is the height of the cylinder, and this phi is the azimuth angle, and this angle is measured from x axis towards this plane, one cut plane. Here is the plane. That plane is moving along the cylinder. Over that, this phi is constant on that plane. Okay, so this phi is changing here as the angle is changing, but for that angle, suppose here is the 45 degrees the angle. Okay, so on this cut plane, whatever this cut section is added in the cylinder, here at an angle, this cut section is at an angle of 45 degree. That means all over this plane, value of phi is equal to 45 degree. So that is also known as the phi constant plane. Okay, we will see that one by one. Okay, so the coordinates, rho is the radius of cylinder, phi azimuth angle measured from x axis, that is the phi, and z, it is the height of the cylinder. So according to the coordinates, we have three unit vectors: a rho cap, a phi cap, az cap. Coordinates for rho, limits 0 to infinity, phi 0 to 2 pi, and z minus infinity to plus infinity. So these are the by default limits. If it is not given, you have to consider the limits as it is. For rho 0 to infinity, phi angle, azimuth angle, it is always 0 to 2 pi, that is the 360 degree rotation, and z, height of the cylinder, it is infinite. Then how to express unit vector a bar in cylindrical coordinate system? A rho cap plus a phi cap plus az cap. And this simple a rho, a phi, az are the magnitudes, where this a rho cap, a phi cap, and az cap are the unit vectors along respective axis. Okay, how to calculate the magnitude of a bar? Under root magnitude a rho square plus a phi square plus az square, right? So as per the dot product, we have the similar unit vector dot product is always 1, and different unit vector dot product is always 0. Like a rho dot a rho, always 1, a phi dot a phi, always 1, az dot az, always 1. And a rho dot a phi, 0 az डॉट ए फाई, जो भी डिफरेंट यूनिट वेक्टर होंगे उनका डॉट प्रोडक्ट इट results to 0. Okay, now one more concept is there. There is a cross product, right? So when rho phi z is there, when we take cross product of rho and phi, resultant is the remaining third unit vector. So as a rho cross a phi, a z cap, but you have to go for clockwise direction. Suppose a rho, a phi and az caps. Okay, go clockwise direction. When we multiply this two unit vector, resultant is this third. When we multiply a phi az, resultant is remaining third vector a rho cap. When we multiply az cross a rho, resultant is remaining third wala unit vector. Okay, but for this positive results, we have to go clockwise direction. When we go anti-clockwise, our answer is negative. Suppose a phi cross a rho, answer is minus az cap. Please remember. Now here, same case for the differential calculus as per the Cartesian coordinate system. Now differential length. Differential length, right? It's going to change according to the coordinates. Now here the coordinates are rho, phi and z. Now as you know, the rho is the radius of cylinder, z is the height of the cylinder. So rho is radius, that means it's a length, like a length it is in meter, and z is also height, it is also in meter, that means it is a simple length. But phi, it is an angle, it is not a length. We measure angle in degrees, not in meters, right? So we have to convert this phi angle in terms of some modification to convert or for the differential length. So it is differential length of phi, it is rho into d phi multiplied by radius into d phi, then we get differential length for phi coordinate. For rho, so if it is length, simple d rho. For z, if it is length, simple dz with unit vector. And for phi, it is an angle, so some changes are there. So take a multiplication of radius rho into d phi, phi ka differential d phi with unit vector a phi cap. Now same case in ds bar, we have to consider this three surfaces. Now this is the cylinder. In this cylinder now three planes are there. Rho constant plane, phi constant plane and z constant plane. So according to that, this is the outer portion of the cylinder jahan pe radius is the constant factor. This is the one cut section to the cylinder. On that phi is the constant plane. And for this it is the one cut section, that is the r is varying and this phi is varying, angle is varying. So here z is constant. So for this we have to write differential surface areas as for r constant. Suppose now here concentrate on suppose rho constant plane, so rho phi z. If it is rho constant remaining to phi ka differential rho d phi and z ka differential dz, in dono ka multiplication. When a phi is constant, that is the phi constant plane, remaining do ka multiplication unke differential length ka. For az, so this az rho ka d rho or phi ka rho into d phi and into az. And for volume, multiplication of these three differential lengths rho d phi dz. This is the volume, is the scalar quantity. So this is the all about the cylindrical coordinate system.